So I want this comparer to check all the fields in food. That's the name and the food group. And I'll paste in code to do that. Now, instead of simply returning the result from comparing the names, I will store the result in a new variable. If that compare value is not 0, then we can just return it straight away, because we've already established which of the food instances should come first in order. But if this value is 0, then we know the names are equal, so you should then try to make up a consistent order based on the food group field. For this, I will just go alphabetically by the name of the group. So I convert the two food groups to strings, call strings compare method on those, and return whatever value I get back from that. Now that's good as it goes. That is the way to implement compare for multiple fields. But this won't actually solve the issue we encountered, that apple and baked apple evaluate as equal, because we have another problem. The difference between apple and baked apple isn't in any of the fields in the food base class. Rather, the difference is that baked apple is a derived type, cooked food, and so has additional fields which we're not currently checking. And this is a real problem. We learned earlier in the course that it's very hard to make natural equality and comparisons work properly with inheritance, and comparers have much the same problem. The only way you can guarantee a consistent sort order in every case is if this comparer has explicit knowledge of the cooked food type and of any other type that derives from food, and so can check its arguments individually for instances of those types. And obviously that's going to get messy. I won't show you the code to do that, because it would be very long and wouldn't really teach you anything useful. But the real lesson here is that writing a robust comparer for a non-sealed reference type is problematic unless you're willing to just check base class fields and ignore any extra fields in the derived types. And in many situations that may well be quite acceptable. But if you are worried about derived types, I'm afraid I can't give you a good general solution because there isn't one. What you do will depend on your precise situation and business needs. You just need to be aware of this problem so you're in a position to decide how best to work around it, given whatever business needs you have. I would point out though that this does show up a strong benefit to having sealed classes, because sealed classes won't give this problem when you try to compare them.